All right, we're going to talk about multiplying polynomials now. And the quickest way for me to say what this is, and it's basically just repeated distributive property. So repeated distribution. All right, we're going to distribute repeatedly. Well, here, though, it's not necessarily distribution. This is a monomial, and this is a number. I just want to make sure we're good that this would be 6x. Oh, my goodness. That says 36x. Let's get rid of that one. Okay. All right, so that one is pretty straightforward. I just wanted to throw that in there just to kind of remind us that we're really just multiplying the numbers. This one, I need to distribute twice. So 3x times x. Remember, x times x, we can rewrite that as x squared. So 3x times x is really 3, because there's a 1 right here, and then x squared, and then let me multiply it by 5. So 3x times 5 is a positive 15x. So that's that one. Here, we're going to distribute the x first to both, and then we're going to distribute the 2 to both. All right, let's do the blue. X times x is x squared, and then x times negative 3 is negative 3x. Now let's shift down to the red. Positive 2 times x is a positive 2x. And then a positive 2 times a negative 3 is a negative 6. Now all we have to do is combine like terms, right? And so if we do that, I have an x squared, because there's only that. I have a negative x plus 2x. That's going to be a minus x. Done with those. And then it's just minus 6. Here, same idea. I'm going to take this thing and distribute it to each, and then this thing and distribute it to each. So negative 2 times 3a, negative 2a times 3a is a negative 6a squared, because a times a gives you a squared. And then I have a negative 2a times a negative 1. Well, negative 2 times 1 is, negative 2 times negative 1 is a positive 2, and don't forget the a. Now let's transition to the red ones, and this is what I mean by the red ones. So 3 times 3a is a positive 9a, and then 3 times negative 1 is a negative 3. So all in all, let me combine some like terms. I only have one a squared term, negative 6a squared, done. I have a positive 2 and a positive 9. That gives me a positive 11a, done, and then minus 3. And then down here, same idea. I know it has a binomial times a trinomial, but you still are going to distribute the x to all 3 and then the 2 to all 3. Let's just do that. X times x squared is x to the third power, because x, 3 x's. And then x times negative 3x is a negative 3, and then there are 2 x's, one here, one there, x squared. And then x times a positive 1 is a positive x, because 1 times anything is just the anything. Now let's do the 2 here. A positive 2 times x squared is a plus 2x squared. Positive 2 times a negative 3x is a negative 6x. And a positive 2 times a positive 1 is a positive 2. Beautiful. Now let's just combine stuff. There's only one x cubed. Done. There's an x squared here and an x squared here. That's negative 3 plus 2. That's negative 1 x squareds. Done. There's an x term. There's an x term. Positive 1 minus 6, negative 5 x's. Gone. And then I still have this plus 2. It is in standard form. We are done. Just an FYI, let's go back to these two. Notice how we did the first 2, x times x, the first 2, the outer 2, the inner 2, and then the last 2 digits. Because of that, and the same thing is true in this example, you might hear the method being used being called the FOIL method. It's just a way to remind you that you need to distribute repeatedly. The reason why I didn't start with that is